Hello YouTube, it's the Atlanta Puzzler here with a new series on how to design and 3D print a Megaminx. The reason why I chose a Megaminx is because it's not too complicated. It is more complex than designing a cube, but it's not too complicated. However, if you master building a Megaminx or get familiar with the different steps and processes, this will serve as sort of like a stepping stone towards getting into more involved puzzles or creating your own puzzles. um, there are some concepts here such as modeling, rotating around, you know kind of more difficult angles, not like a cube everything is 90 degrees. Megaminx is what they call a dodecahedron, which dodeca means 12, and it's basically the solid that has 12 surfaces, and they all look like a pentagon. So I guess this is the final result. This is what I'm hoping you guys can be what you guys can accomplish by the end of this tutorial, and you'll be able to 3D print it. And you know, if if it looks daunting, don't let it don't feel that way, because it is really similar to a cube, but it's kind of a step up. So to get started with this series, we have to let's create our own document first, and I want to call this. Let's call it. Okay, let's call it the dodecahedron first. Create a public document. And the reason why I called the document this, I want to go with you guys over how to create a solid called dodecahedron, which is something that will be useful in the future, not just for a Megaminx. So once we create it, we'll version the document and publish it and put it somewhere so that, you can have it in your stash and you can reuse it in the future. You can make your own, you can use mine, or by the way, you can just use someone else's. I'm sure there are hundreds of them in OnShape. So here's the new document. I clicked here in the front plane. And to get started, we need to basically build a cube and build 12 surfaces and cut the cube with these many surfaces. And that will give us a dodecahedron. Okay. So to get started, let's create a sketch on the front plane. And I'm going to call this cube, or sketch cube, I'm sorry. I'm gonna kind of rush through the cube part because I'm sure you guys are familiar with this process. So in the sketch, let's do a center point rectangle. So make sure it snaps at the center, and let's just draw a box here, a rectangle. And I'm gonna choose these two ends and make sure they're equal, meaning a square. And let's constrain this edge with, I think um, I think Shengshao, the Megaminx is maybe 70 millimeters, so I'll just use that for now. And next, after we have the box, click on extrude and make sure it's 70, and we'll make sure this is symmetric. And let's make this create cube and do OK. And here we go, we have a box called cube. Okay, I'm gonna rename this part here to cube as well. Next, I want to create a new sketch. We can use the same sketch, but I like to keep things separate and clean. Let's choose the front plane, and let's call it sketch Z plus, and this will make sense in a moment. We're gonna build cutting surfaces in the positive z-axis direction. That's why I called it Z plus. I don't know what else to call it. And sorry, let's click on the line here, and let's zoom in a little bit. You want to start. You want it to start with the edge of the cube, but initially it's okay to. It's okay if it's not. Just make sure it snaps on the z-axis, and make sure it goes this way. We'll fix that later. Create another, actually let's not create another line, I'll just mirror it. Zoom in, click on this point and click on this point, the point between the cube and the axis. You can press I to make them coincident, or you can press this. Let's zoom in here as well. Actually, you don't need to do this for dodecahedron. What you need to do is click on the mirror, select a mirroring line or a mirror line, click on the vertical axis and select this line to mirror it, and now you have two symmetric lines. Okay, press escape. There you go. Now next, click on the first line and second, click on the dimension icon and choose these two, which you can select an angle. And for a dodecahedron, it is 116 point, I think 56. Some people use many decimal points for accuracy. I think this is good enough. And there you go. This looks like a, I guess like an inverted letter V or something. So let's click OK for this sketch. Actually, I wanted to add the axes as well, but we can do that in a separate sketch. Let's click on the extrude and make sure it's a surface. Curves to extrude. Click here on the sketch Z plane and make it something big. You want it to go beyond the cube, so make it 70 more than 100 more than 70. And instead of blind, make it symmetric. And let's call it create Z positive surfaces. Okay, and there we go. It should look something like this. Okay, next let's click on the mirror icon, which is this one. Entities to mirror, choose the surface, and now it needs to know which mirroring plane, and let's choose the top. This is the top plane here, and let's rename it to create Z minus surfaces. Okay, and do okay. And if you look, we should have an inverted version of what we created earlier. So we have this surface and the surface below. That makes sense. Maybe if I hide the cube, it looks better. Maybe not. Anyways, it looks something like this. Let's put the cube back. Okay, now next we have to take these two surfaces and create another pair for the z-axis, for the x-axis, and another pair for the y-axis. And the way we do this, we have to copy these and rotate them, but then we have to rotate them twice, basically, over two axes every time. But before we do that, let's create some sketches here. Let's sketch in the front plane a line. That's construction line from the center all the way to the top for the Z. Let's do that again for the X, and press escape. Sketch XZ axes, and let's make another sketch, but this time on the right plane, and make a construction line from the origin. Make sure it's horizontal, and that will be the y-plane, y-axis, I'm sorry, and do OK. Alright, so I hope this makes sense. These are just simple axes, and you can use we can create a feature script for that if you guys like, and we'll talk about those in a moment. But anyways, okay, let's figure out now how to rotate these. Do the transform, which is this, and transform the entities. Choose both surface 1 and 2, and we want to change this to rotate, and let's rotate it around the z-axis first by 90 degrees, and check copy part initially. Okay, and let's call this create X surfaces. Sorry, I can't type today. Okay, and here are the two surfaces. It's just a copy of what was in the z-axis, but they're here. But now next we have to rotate this along the y-axis. So let's click on the transform again, choose these two entities, rotate over this axis, sorry, by 90 degrees, but now you do not want to check copy part. Let's just say rotate X, and here's the shape. It looks this way. Let me show these two again. Okay, now for the third part, we need to take, you can start with either of the surfaces, but we basically need, let's start with the original, with the z ones as well. So click transform and choose surfaces 1 and 2, rotate them over the z-axis. Let me hide these two, and let me show the sketches. Sorry. Okay, here we go. Okay, I want to choose surfaces 1 and 2 over this axis by 90. Make sure you check copy part, and let's call this create Y and do OK. So here are the two parts, but now we want to rotate them along the x-axis. So let's click on transform, surfaces 5 and 6 along this axis. We do not want to copy part, sorry, rotate along this axis by 90 degrees, and rotate, call this rotate Y and do OK. Okay, what did I do wrong? This is fine. Oh, yeah, this is correct. I'm sorry. I didn't see those. Okay, so now you should have 6 surfaces. This one and this one that will cut along the y-axis. This one and this one, which will cut along the z-axis, and this one and this one, which will cut along the x-axis, which basically means all my naming convention was wrong, but it's fine. It doesn't matter. Okay. Now what we want to do is we want to cut the cube with all these surfaces, and we'll be done. But we talked about this in a previous video that I had. If you haven't seen it, I'll link it in the description. You can take a look at it. But basically, the split tool that exists here, I chose a cube. It will only allow you to choose one of those surfaces. And if you choose one of those surfaces, if I choose one of those surfaces, I cannot choose more, right? That's the only one I'm stuck with. That surface already cut the cube, and next time I want to cut with it, I have more and more surfaces to cut with. So I can choose these these 3, cube 1 and 2 and 3, and choose the next surface, and then I'm going to end up with 7. And you can do it that way. I mean, that's easy enough, I guess. But instead of doing that, I created a tool in a previous video that allows you to multi-split. So I'll just use that, and I'll show you how to import it, and then you can just use that. And if you want to do it manually this way, that's fine. But I think you know. So anyways, to import the document, I clicked on this plus sign that says add custom features. Other documents, my OnShape. In your case, you'll go to other people's OnShape and type Atlanta Puzzler, whatever. But then there's under tools, like, there's Atlanta Puzzler tools. And under I have something called dice or split mini. Choose that one. And you can close the dialog, and you'll see here I have the dice tool, split mini. It shows like a D and then a parentheses because of the split mini, but and that's okay. So let's click on it, and it tells you what parts you want to dice. Just choose the cube, and what surfaces you choose all six. And as you choose, it's actually dicing. I have two more, and the last one, and we're done. So we'll call it dice cube and do OK. And now you'll see you'll end up with this. Let me hide the planes. Let me hide the axis here. Okay, you'll end up with this. And what you'll have to do now, delete all superfluous parts, and you'll end up with the dodecahedron. So I'll click on delete part. Now, and it is to delete. I don't need this. This is not going to be clear, is it? Okay. And let's do one surface at a time. Sorry. Okay, there we go. Here's one side. Let's do these. It's really tedious, but it's okay. Okay, let's do these. And let's see. Sorry. There's this. Okay, let's do the top. Did I? Okay, that's correct. And I think I missed something. And this, okay, there you go. And the bottom. Did I get everything? I think so. Let's do okay. And there you go. Here's a beautiful dodecahedron with all 12 faces and pentagons that you made yourself. And you don't have to import anyone else's documents or parts, or even if you do, you can at least now you know the process, you're familiar with it. Okay, so let's call this dodecahedron. This is like a blank dodecahedron that you can use for many future puzzles. So let's delete this tab that we don't need. I want to clean up around real quick, and let's rename this I don't know, default or something, whatever. Okay, click on version here. Let's call it version 0.1. Create dodecahedron. Actually, let me cancel real quick. Sorry to do this. Let's call this, let me rename document to, I have something called reusable parts. Let's call it common shapes. How about this? Okay, common shapes, rename, and let's rename this guy. Makes sense. Dodecahedron, enter, and finally, that's version. Since this document will contain many common shapes, we have dodecahedron. I'll go ahead and add several in the future, not now. But now for first revision, let's call it 1, fine. Add dodecahedron. So hopefully this is a document we can grow in the future and add more and more shapes. Okay, now that I version them so that you can use them in the future. You can go ahead and import in your documents. Okay, so now when you come in here, you have a common shapes document with dodecahedron. I'll go ahead and move it. to reusable parts and move here. Okay, so now it lives in here. You can search for it, and you can use it yourself, but I encourage you obviously to follow the steps and use them. So I'm sorry for the long video, but this is part one. This is how you create your dodecahedron. In the next part, we'll sketch a cutting profile and model it across all surfaces and dice the dodecahedron, and that will give you all the parts for a Megaminx, and you can, you know, clean up the parts and wrap up the video. I hope you guys enjoyed this. I hope you found it useful. I know it's just, the first step here, the the dodecahedron, but in the next parts things will get more exciting, I promise. Okay, so I'll look forward to seeing you in the next videos. Thanks.